In this video, we're going to use Excel to take given equations or given patterns and fill in an Excel table. And second, given an Excel table, see if we can identify the pattern in the given table. So I'm going to start here with an input-output table that's been partially created already. We have input x's that it goes 0, 1, 2, 3, and up. And the y is equal to 720 times 1 plus 0.08 over 4, all raised to the 4 times x. So here in cell D17, I put my cursor. I want this cell to equal, remember you start your cells with an equal sign to write a formula, equals 720 times, parentheses, 1 plus 0.08 over 4, parentheses, and we're going to raise this to the 4 times x. So raise is this little caret symbol. I want the entire exponent to be 4 times the x value. So I got to put that in parentheses, 4 times symbol, and I'm going to click on cell C17 so that it pulls the x value from cell C17. So you see there's parentheses around my exponent, so that all is up in the exponent. And when I press enter, it tells me that the y value is equal to 720 when the x is 0. Remember to drag down this formula. You put your cursor in the bottom right corner until it looks like a little black cross. I hold down my left mouse button and drag it down, down, down to fill in the table. So for example, when I drag that formula down, if I now click in the cell right below that first cell, in this cell, it's the same formula except in the exponent 4 times x, the x value is referencing cell C18 where x is 1. If I go down one more cell, now the x value is referencing C19 where x is 2, and so forth. All right, so it filled in this input-output table with this given formula. Let's try again. In the next table, again, I have some given x's, x equals 0, 1, 2, 3, 4, 5, etc. And it says we want this to start at 30,000 and decrease by 1.9% every time x increases 1. So it starts at 30,000. So the first thing I can write in this first row is the number 30,000. And it says every time x goes up 1, we want this y to decrease by 1.9%. So this next cell down should equal, remember, start with equal. It should equal the cell above it. So I click the cell above it, and then I want it to go down by 1.9%. So it equals that 30,000 value minus 1.9% of that value. So I subtract 0.019 times that value. So it takes the cell above it, 30,000, minus 1.9% of 30,000. If I now drag that formula all the way down, notice if I click in the cell where an x is 2, it's now taking J18, so the cell above it, minus 1.9% times cell J18. So every time it's taking the cell above it minus 1.9% of the cell above it. So it's decreasing it by 1.9%. I just want to also notice there is another way to do that. Instead of taking the y value minus 1.9% of the y value, you could write the formula as equal to the y value above it times 0.981, because taking 1.9% less is the same as taking 98.1% of it. 98.1% of 30,000 is the same thing as 1.9% less than 30,000. So you would get exactly the same numbers if you just wrote the formula that way. See, these match up. Same thing. So either way you wrote that formula, you would get the same answers. All right, next, let's try two examples where we kind of do it backwards. Here in example A, I've been given set of points, input output table. X is 0 and the Y is 85,000. When X is 1, the Y is 81,520 and so forth. And there is a pattern that exists here that I haven't told you what the pattern is, but we're going to go ahead and figure it out. So, the way I'd like you guys to approach these in this class, the only types of patterns I would expect you guys to identify in this class is a linear pattern or an exponential pattern. These are kind of the two simplest types of mathematical patterns that I want you to identify. Linear pattern means there is a constant amount added or subtracted as the x values increase by 1. An exponential pattern would mean there's a constant amount multiplied, which you could also think of as dividing, but we're going to think of it as a constant amount multiplied as x increases by 1. So notice, first of all, the x's are increasing by 1. So my question here is just, what is happening with the y's? Are we adding or subtracting a fixed amount over and over and over? Or are we multiplying a fixed amount over and over and over? So first thing I'm going to do is ask, is it linear? Question mark, question mark. If it is linear, that means I am subtracting a fixed amount. So it started at 85,000 and then it went down to 81,520. And then at 81,520, it went down again to 78,040. So the question would be, well, what would be that amount that's subtracted? To figure it out, I'm going to write a formula here in column D. I'm going to skip over the first cell, skipping over the cell D40, and go right down to the second cell. My formula is going to equal this second y value minus the first y value, because that's going to tell me how much was subtracted. What is the difference between the y values? The difference, the subtracted amount. So I subtract the two. Press enter. I'm going to drag the formula down. And again, let's just check it. If I go down to this cell D42, it's taking this y value, 78,040, minus this y value, 81,520. If I go down one more, in cell D43, it's taking this y value, 74,560, minus this y value, 78,040. Every time that it subtracts the two y values, you get a constant value of negative 3480. That means this is a linear pattern. Every time x increases by 1 unit, we subtract 3480 from the y value. That's the pattern that exists in example A. It is not exponential. A pattern cannot be both exponential and linear. It could be linear, or it could be exponential, or actually it could be neither. There's lots of other patterns out there, but it can't be both. So if you find that it's linear, you're done. It's linear. Every time x goes up by 1, we'll subtract 3480 from the y value. Linear. All right, let's try it again. So on example B, my first question is it linear? So let's try the same thing. I'm going to skip down to the second cell and I'm going to equal the second y value minus the first y value. And then I'm going to drag the formula down. Notice this time that I didn't get the same fixed number. What this is saying is when x increased from 0 to 1, y decreased by 3,400. But when x increased from 1 to 2, the y only decreased 3264, a different amount. When increased from 2 to 3, the y only went down 3133.44. So it's not going down a fixed constant amount. We're not subtracting a fixed amount. So I can say right now it is not linear because we are not subtracting a constant amount. All right, so it's not linear. I'm going to delete out those values, that formula, and I'm going to now ask, is it exponential? Okay, so let's see. Again, we're going to skip over the first cell down to the second cell. If it is exponential, that means that we're multiplying by a fixed number. let me come over here and just kind of point out what would be happening. If it's exponential, then you would start at 85,000 and multiply by some number and get an answer of 81,600, the next y value. So if I want to know what is that number that we multiplied by, the way to figure it out would be to work backwards, divide it. That number is equal to 81,600 divided by 85,000. That's how we'd figure out the number we multiplied by, right? Work backwards and divide. So I'm going to do that. My formula here in this cell D55 equals the second y value divided by the first y value. I'm going to drag my formula down, and yes, indeed, this is exponential. What that 0.96 number is telling me is that this is an exponential pattern. Every time x increases by 1, we multiply y by 0.96. So notice, as x increased from 0 to 1, if you start at y equals 85,000 and multiply by 0.96, you'll get 81,600. As x went from 1 to 2, if you start at y equals 81,600 and multiply by 0.96, you get 78,336, and so forth. So this one is exponential because we have a constant amount multiplied, and this one, example A, was linear because we have a constant amount subtracted.